Greetings everybody, and welcome to our fourth example in our series on dot products. So what we have in this problem is that an airplane is flying at 300 miles per hour at 30 degrees north of east over a road that's oriented at 20 degrees south of east. And what we're asked to find is how fast is the airplane traveling perpendicular to the road. So what we're kind of imagining here in this case is if we wanted to write down the velocity vector for the airplane. So in that case, if we're imagining a horizontal and we're going at 30 degrees, then our velocity vector for the airplane is going to be 300 times the cosine of our direction vector, 30 degrees, and 300 times the sine of our direction vector of 30 degrees. Now, for the direction vector of the road, we imagine that we have a horizontal line heading off in this direction, and we know that that angle is going to be 20 degrees. So our direction vector for our road, is actually going to be, again, the horizontal, really just being, I can make it the cosine of 20 degrees. And for the vertical, since I'm going down, I know that it's going to be negative the sine of 20 degrees. And so what we're really kind of asked for in this case, well, we know the magnitude of our vector v for our velocity, and so one thing that we can do is to find the component of our velocity vector that's in the direction of the road. So if we do that, if we look at the component in the direction of the road of our velocity vector, that's going to be r dotted with v divided by the square root of r dot r. Well, since r is a unit vector, because we chose the values of cosine 20 degrees minus sine of 20 degrees, r is going to be a unit vector. And so what that means is the length of r is going to be 1. And so what we have for that dot product is that r dot r is going to be 1. So the only thing that we really have is the scalar component for that value. And so what we then have is this equal to r dot v. And so what we have for that value is 300 cosine of 30 degrees times the cosine of 20 degrees plus 300 times the sine of 30 degrees times the negative sine of 20 degrees. So what this gives us, and if we kind of plug those values in the calculator, what we have is a value approximately of 1.92.8362829. Now, if we kind of look at the picture for what we actually have then in this case, so what we have is our airplane's velocity vector that's heading off in this direction. And then what we just found is the component that's going to be off in the direction of the road. So we have this component in the direction of the road of our velocity vector. And so if we want to know, then what is the magnitude that's going to be perpendicular? Well, we have our right triangle. So we've got the magnitude of the velocity vector, which is going to be 300. We just figured out what the component in the direction of r of v was going to be. And so by the Pythagorean theorem, we know that our vertical side then is going to just be 300 squared minus the component in the direction of r of v. And so what this gives us is going to be the square root of 300 squared minus 192.8362829 squared, which is going to give us approximately 229.8133329. So I hope you've enjoyed this video, and I will see you guys in the next example. Take care.